Okay, let's continue. Before we go into the detailed analysis, we need to also look at the certification requirement, because whatever we do here in analysis is to show compliant. Okay, show compliant to the airworthiness requirement or certification requirement. So everything that you do here, we should be showing compliant to the requirement. So what is the problem when you do repair, mod or anything on the aircraft? The certificate of airworthiness of aircraft is no longer valid until the repair is approved. Repair also can be a modification. So first, once you repair, you maintain the aircraft, the current certificate of airworthiness no longer valid until you repair, and the repair is approved by the organization issuing the certificate of airworthiness. So unless that you are so you have to before you do the detailed analysis, first in mind you must think that you should show compliance to the aviation requirement, design requirement of the aircraft. So what you need to understand, every aircraft is designed to a certification basis. In the cert basis, there is airworthiness requirement. For large transport aircraft, we talk about CS Part 25 or FAR Part 25. This is normally from aircraft from Europe, Airbus. This is aircraft from USA. For the Boeing is using the FAR Part 25. So aircraft design, the design requirement Part 25, there is several subpart. Subpart A, subpart B, subpart C, subpart D, subpart E, subpart F, subpart G. A is general, explain about the design requirement. B is a flight, anything to do with the flight performance, maneuver, stability and control is under B. C is structure, anything to do with the structure, any design requirement for structure, you go to subpart C. Subpart D is design and construction, design the aircraft and the fabrication of the aircraft. Subpart E is power plant. Power plant talking about engine and engine system or accessories. It's not the engine by itself. Engine itself, there is a design requirement by itself, but you put engine on the aircraft, put an nacelle, put on the aircraft, and the certification of that engine installation to the aircraft is under subpart E. Subpart F is equipment. Equipment or the avionics or electrical, circuit breaker, everything under subpart E. G is manual. All the maintenance manual, structure, repair manual, illustrated part breakdown, catalog, illustrated part breakdown, wiring diagram manual, MMEL, MPD. So everything is under subpart G. That's why we have those requirements. But it's not just because OEM wanted to publish it for you, but they have to publish it because they need to satisfy the subpart G for them to be able to certify the aircraft. So as the aircraft got damaged, the COA is no longer valid. So whatever data, okay, we go back to what we have done. So we have this repair. Yeah. Go back to the repair. If this is aircraft part, okay, we have double install, 4 rivets. Okay, we can see from the top, 4 rivets. So this is the original part, aircraft part. Now you're repairing. Is damaged, need to be repaired. Why? Because if you damage a part, the factor of safety is no longer 1.5. That's for sure. So mean the aircraft is no longer as per the design requirement. So you have to repair for you to be able to maintain the factor of safety 1.5. As you do the repair, you're installing something. You're installing the doubler, you're installing the rivets. It was not there. This piece that you install was not there. So that's why repair also can be considered as a modification. Because it was not there, you put it on. So you have to look at paragraph by paragraph, subpart by subpart. Let's look at a B first. So this is what, before you do the analysis, before you do the detail stress analysis, before you do the detail, you have to go through the design requirement, part 25. For the case of Airbus is CS part 25, and for the FAA is FAR part 25. The content are almost the same, so I just put in the general content. So first you must look at subpart B. Subpart B, there is paragraph 25, which is talking about, okay, weight, maximum weight. Then we have 27, C of G of the aircraft. Okay, as you go through, and we have 29, which is talking about empty weight. Okay, now you look at your repair. Does the repair change the aircraft weight? Does the repair change the CG? Does this repair change the empty weight? Okay, for this small plate, I don't think we change the max weight. I don't think we change the CG. I don't think we change the empty weight. So we can consider, after review, this is not applicable. Okay. Then we move on to subpart C. I just chose which is relevant, so I just show you. Otherwise, it will be very lengthy discussion on this one. So we go to subpart C. Subpart C is talk about structure. So what is affected? We got 25301, which is load. We got 25303, which is factor safety. We got 25305, we talk about strength and deformation. Okay, STRENGTH and deformation. I just put the deform. And then 25307, proof of structure. Okay, those are in the structure. 25301 loads, 25303 factor safety, 25305 strength deformation, 25307. So that area need to be shown. Load, we have done the load. Remember, we study the load loss, and then we study the doubler load. So that's satisfied. And then we do the factor safety by doubler load over the load loss. So we have factor safety is 2, around 2 for our study, which is should be acceptable because it is higher than 1.5. Minimum requirement is 1.5. And then 25 treasury strength and deformation. Now we have to do the analysis. Remember, we are talking about failure loads, about 6 failure load. We have to do the analysis. We have to show it has a strength, and then it does not deform permanently. And then 307 proof of structure. Either you have to do by analysis or test. In this situation, for the small piece and maybe just a secondary structure, enough with analysis. If you do very critical structure, you may end up to do the proof of concept and do the test. So that is C. That's how we satisfy C. And then we move on to D, design and construction. Okay, you move D. I'm going very fast because of the time. So video time. Okay, D. D, we have what? Design and construction. design and construction. So we have what? We have 25603, which talk about suitability. Okay? Material suitability. Material suitability. Then 605. 605, which talk about the fabrication method. Okay, and then 29 is Haley. 607 is a fasteners. Then 25609. Okay, 25609 is a protection of the structure. So that is what we have to consider when you go to the subpart D. Okay, for this situation here, 603 material suitability. I'm not talking about new design. If we talk about new design, and then we are more complex. That's why material suitability is no issue, because we use material as available in the structure repair manual. That's why I say that we use whatever material listed in the structure repair manual. We are trying to use aluminum alloy from the manual. We've gone through the manual. We end up not able to get the good thickness. We have very thick tubular using aluminum. We change it to AISI 301. Those material, the strength, the value, the type of material also from the SRM. So no problem. We comply. Fabrication method, that's why for the fabrication, you always go back, refer to the manual. All the standard practices and manual, you go back and refer, then we have no problem with the fabrication methods. Fastener, whatever fastener that listed in the manual, you use. If you're not using whatever listed in the manual, then you have to do different justification. You may have to do another test, you may have to do detail analysis. The best is you do whatever available from SRM, then you have no problem. 609 protection structure, that's why we have mentioned earlier, since you are using AISI 301, that is stainless steel, and there will be a dissimilar metal issue, then we have to cadmium plate the AISI 301, and the cadmium plating process, everything are also from SRM, so we have no issue. So this is easier, rather referring to design and construction of the repair according to the structure repair manual. Next, we look at the subpart G. Okay, what is important subpart G? Subpart G talking about information. Okay, subpart G talk about the operating limitation and information. Ops, limitation, and info. So for us, we refer to, for this repair, we refer to is 1525. Okay. 1525, instruction for containing airworthiness. Instruction for containing continued airworthiness. So you must have a manual, you must have some information how to make sure this repair is continually to be airworthy. So it must be like a maintenance manual aspect of it. First, if you look at this, first you need to also to tell inspection, to have some inspection requirement, and then inspection method, and then you have to look for the limitation. For example, if you see corrosion, if you see crack, what are the allowable limits? So those are in the ICA, and how you clean the area if need be. Okay, cleaning. Okay. And then inspection method. So everything here are part of instruction for containing airworthiness to ensure the repair is continually airworthy. Also time limitation. We call this as airworthiness limitation. Okay, airworthiness limitation, limit. So airworthiness limitation is the inspection interval. So how many hours that you go back and inspect this? You know why you need to inspect? Because you do the repair, you only do the static. You may do damage tolerance and all this fatigue analysis. However, remember, as you cut more hole, you are putting a stress. Any cut, any corners, any hole, you put in more stress. So as you put in the stress, remember, if you go back to the SN curve, stress cycle. So as you put more stress, okay, if this is a stress now, because nothing plain, but now you put more hole, you have increased the stress. So increase the stress, you can see the life is reduced. So you have to put some determination what will be the inspection requirement, because that area is no longer able to move, able to operate without any limitation, because you already have putting stress here.